Hello folks, we're starting part 13, and we'll be taking our image from the linear to the nonlinear state using the process in PixInsight called the Histogram Transformation tool. So let's head over to PixInsight, and we will take a look at this is our image. And this image is in the linear state, and when I reset the screen transfer function, it takes the image back in an unstretched state. The only stars you see are the ones that are more than likely saturated or they're overexposed. When you hear the term saturated in astrophotography, think of just overexposed and clipped. In regular photography, saturated means the colors have been enhanced to the point where they're too brilliant, too bright, not so much in luminosity but in the color, too intense. But in astrophotography, and being a photographer, I think of saturation as being just that. Colors pushed to their extremes, and but in PixInsight it just refers to having clipped the color to where you've lost data. So we're going to use two methods of the histogram transformation. Both of them are good. They're probably both equally good. You just choose the one that you prefer, and one's kind of easier than the other. Requires very little input on your part, but for some reason I've always chosen to apply the histogram transformation incrementally, and I'll show you what I mean. Let's first do it the easier way, and it involves bringing up the histogram transformation tool, and then we're going to view our image. And this is, before I do that, I want to make two instances of this. I'm going to make another instance because we're going to do it two ways. And sorry, this is the clone. And we're going to pull up, if we can find it here. Let's go back. Lost it. It says clone, and we want the one that says clone. So we're going to click on reset. We're going to reset it down here, reset it up there, and let's bring up the real-time preview. Now let's go to the screen transfer function, and let's ask PixInsight using this tool to adjust the R, G, and B channels and the luminosity channel to create an image with little or no clipping. So this is kind of an automatic feature. We've been using it all along. So let's click on this radioactive looking ball, and that is the image that PixInsight has determined renders the best overall stretching of each of the colors R, G, and B, which in our case is HA and sulfur 2 and O3, not in that order. Sulfur 2, HA, and O3, that's the order of the Hubble palette. And so what we're going to do is we're going to apply this to our image. So I'm going to kill the real-time feature. We really don't need that when it's automatic. I'm again going to reset this. I'm going to apply it again. I'm going to drag this down to the bar. Again, I took this process, I clicked on it, and I drug it down to the bar. And so I have taken everything in the screen transfer function the recommendations it's making, and I've applied it here to the histogram transformation tool. And now we're going to apply it. So let's unstretch the image. Let's take this triangle and drop it on our image. And it's stretched. We can test it by making sure this image is active. We got a dark blue bar, and trying to reset it, and it won't go back to the linear state. It is now non-linear. So let's just rename this clone a kind of just call it auto. I don't know another name to call it. Histogram Transformation. And so this is our auto stretch, and then we're going to bring up this image, and we're going to do this incrementally and manually. So it's unstretched, which is the way we want it. Let's bring up our real-time menu, real-time preview, and let's reset this, and let's find the clone, which is what this image is called. And I really don't need the real-time preview, because I know when I start moving the sliders what I want. So I'm going to take this slider and I'm going to move it over, making sure that I don't clip any of these colors, and I'm going to incrementally start applying a stretch. Okay, I'm going to reset down here at the bottom right, and I'm going to move this slider again, and the line has a bump right there, and I am headed to that bump, and it's about right there, and I'm going to stop. Where that bump occurs is where the slope begins. So I'm going to, and where the slope begins, anything beyond that, if I move beyond that, I'll be clipping data, and that's what I want to avoid. By the way, as I do this, I have no interest in how contrasty this image is. I just want to make sure that I've brought out all the colors and haven't clipped any of those. So that's goal number one. I'm moving the histogram towards the center of this luminosity schedule. By the way, down here you see a bar. It's dark over here, and then it gets lighter. These are the levels of luminosity for this 8-bit image. It's got 8-bit 256 levels of luminosity along this image here. So you can count on that. There's 256 levels. If you had this converted to 16-bit, then there would be 64,000 levels of luminosity. But we're fine at the 8-bit level as we stretch this. Okay, we're going to apply this. And we're going to reset. And this time we're going to bring the dark slider over to a safe place and park it. Again, I don't want to compromise any of the blues. The blue slope starts first, and then I'm going to bring this back to the bump and apply. And then we're going to reset. We're going to move this to where the blue line starts, and we're going to move this to this bump, and we're going to click apply. And we're going to back this off. Let me see where we are. Yeah, we're going to back this off some, and we're going to back this off some to this bump, and we're going to apply. We're done. We're about done. I don't think there's we're flattening out these curves for both red, green, and blue. Are you surprised to see all the red in this what otherwise looks like a green image? There's a wider range of green from here to here than there is red, but there's a definite presence of both red, green, and blue from the RGB channels of our hydrogen, sulfur, and oxygen. So as we start bringing this image out, we shouldn't have any problem identifying and bringing out our reds, our greens, and our blues, because they're there. They're in the data that we know. Now, if we had a flat line for blue, it would be pointless to try to retrieve it, any of that data. So I'm happy with this. Let's see what we got. That's what we've got, and I'm happy with that. And again, it's not going to be as contrasty as the auto color, but that's okay. I'm more interested in preserving all of the colors and using those colors later. I can add contrast with curves. So with that being said, we will put histogram transformation now to bed. We now have two images that we've done, one incrementally with the auto color, and then one that with incrementally that I did, and then one with the auto transformation. You can see that the auto transformation does bring out more contrast, and I don't think I don't see any significant data. I don't see any data lost. It looks like a good stretch to me. I know that I didn't lose any data over here because I saw what I did, and I know exactly what's in this image. Had I done nothing but this stretch, I would have had less confidence that I would be able to identify, locate, and pull out reds and blues from what looks like a dominating green, and it is dominated by green, because we know hydrogen alpha and sulfur were the two principal emissions that hit the sensor. There was very little oxygen, although we know there is some because we saw the blue in the blue in the histogram. Okay, well, folks, that's the end of part 13. If you would please click on like, and if you subscribe, you'll be notified of other videos. I don't do a whole lot of this teaching. I am going to go completely through my workflow with PixInsight. I'm more akin to doing live streaming of imaging sessions, either of the sun or of deep space, galaxies, or planetary stuff. So I like to do the live stuff, and if you click subscribe, you'll be notified when those are going to happen. With that being said, have a great rest of the day, and clear skies to everybody.